So girls, you thought I wasn't going to be at school today, but that doesn't mean that you're not going to hear my voice. So in this video here, what we're going to do is, as the name suggests, find the equation of a straight line graph. Okay, so basically what we're doing is we're looking at an already drawn graph or two coordinates, and what we want to work out is what is the equation of that line, or what is the equation that matches that line. So it's really important that we understand that to do this, we need two coordinates. Okay, that's what we're after. If we've only got one coordinate given it to us, we actually can't solve that problem. Okay, so we need two coordinates. Once we get the two coordinates, the process is really mechanical. All right, so what we do first of all is we find out the gradient, and second we find out what the y-int is. Okay, and then we express our answer in y equals mx plus c form, or whatever form the question asks us to write the answer in. Okay, so here's our first one here. Okay, so first of all, if a graph's drawn, what we're going to determine quickly is we've got a negative gradient here, so that's one thing I know. And what I need to pull off this graph is 2 points. Okay, now it just so happens they've given us this one here, which is when x is equal to 0, y is equal to 6. And they've also given us this one here when x is equal to 3, y is equal to 0. So our first step is to work out the gradient. Now you'll recall m equals y2 take y1 over x2 take x1. Right, so we're going to make that x1, y1, x2, and y2. All right, so here we go. We're going to sub in these values. Okay, so it's 0 take away 6 over, 3 take away 0. That's negative 6 over 3. That's negative 2. Right, so we're going to note now that our equation in y equals mx plus c form would be written as follows. Y equals negative 2x plus c. Okay, so what we've done is we've worked out the gradient there, and I've substituted that. And the final step is to work out the plus c. Now, I'll show you how to do this. We're going to pretend like we don't know what the y-intercept is, but I can actually see the y-intercept straight away. It's 6. Okay, we're going to pretend that we don't know that, and what I'm going to do is use the substitute a point method. Okay, so what I'm going to do is sub in this x-intercept into, so I'm going to write this down, sub 3, 0 into that. Right, and what it's going to do is it's going to tell us, well, it gives us a value for y and it gives you a value for x, and what's left over is going to be this c, so we want to solve for c. So let's see what happens. All right, so I'm going to put 0 equals negative 2 times 3 plus c. 0 equals negative 6 plus c. I'm going to add 6 to both sides. C is equal to 6, okay? And we know that the y-intercept is 6 already, but this gives us the ability to do it with any 2 points, whether it's the y-intercept or not, okay? So now that we've found out our y-intercept, we can write this formula down, or this equation down, y equals negative 2x plus 6. That's the equation that produces that graph over there. Next example. So this is a situation where we've got two coordinate points, okay? And it might be worth your while actually just producing a quick sketch of the graph. So that's that point there, and 1 and negative 1 down there. I know it's not to scale, but this will tell us that our gradient is going to be negative. Now that's good because it allows us to check whether we've made an error or not. Okay, so remember we want the equation in y equals mx plus c form. So the first thing we're going to grab is the gradient. So the gradient m equals y2 take y1 over x2 take x1. Okay, so let's call this x1, y1, x2, y2. Okay, so we're going to do negative 1 subtract 5 over 1 subtract negative 2. That's negative 6 over 1 subtract negative is the same as 1 plus 2, which is 3. This has also got a gradient of negative 2. That's a little boring actually, but anyway, we'll deal with that. Now you might think, all right, well, so y equals negative 2x plus c. We're going to sub the gradient into there. And I need the y-intercept. Note that neither of these coordinate points are the y-intercept. So again, what we're going to do is sub one of those coordinate points in. Generally, I look for the ones that have either got positive numbers or smaller numbers. So I'm going to sub this coordinate point in, given that they've both got negatives. So 1, comma, negative 1. So we're going to say that y, or remember this is an ordered pair, x and y values. So this is a y value here, negative 1 equals negative 2 times 1 plus c. Negative 1 equals negative 2 plus c. I'm going to add 2 to both sides, and that tells me that c is equal to negative 1. Therefore, my equation is y equals negative 2x plus 1. Okay, so it's a fairly sort of repetitive process, but if you use this method, you really can't go wrong. Right, this is actually one of the later examples in another textbook, but it's actually an easier question. So they said find the equation of a straight line passing through this point here, and it has a gradient of 3. So this is great. I don't even need to do m equals y2 take y1 blah 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 blah. Okay, I don't need that because they've already given me the gradient. So I know that already m is equal to 3. Recall the general equation is y equals mx plus c. So I can simply rewrite this now as y equals 3x plus c. Now, a common mistake is to say that the y-intercept is, excuse me, this value here because it's the y value. But for this to be the y-intercept, you need to understand that that there can't be 5. It has to be 0. Okay, so this isn't indeed the y-intercept. So we're going to use the same approach that we've done in the last two questions, which is to sub 5, negative 1 into that. So that's negative 1 equals 3 times 5 plus c. So recall that's x and that's y. So I've subbed y there and I've subbed x there. I'm going to now subtract 15 from this side. So my equation is, sorry about that, girls. Take 16. There it is. Right, so again, just use that same process for all of this style of problem, remembering that you need 2 points to get a gradient, okay? But if you already got a gradient, you simply slam the gradient straight into this, and you've got 1 point to find out what that y-intercept is. Okay, so the work today, I think, or I recall that you've done those already for homework, so you don't need to do those ones. So it's just 4, 5, and 6. Girls who are intending to do methods in 2020, can you do that question there, question 12? And I've also got a worksheet that will be passed on to you in class. All right, so good luck with that, girls, and I hope it goes well. See you on Monday.